Thanks, Grace. Welcome, everyone. I'm going to be talking about Selenium a lot today. First of all, who am I? My name is Santiago Suarez Ordóñez. I'm a lead backend developer at Sauce Labs. I started at Sauce almost 5 years ago. I'm actually the employee number one, working from Argentina for 3 years, so that was quite a challenge. And then I moved to San Francisco a year ago. I've been a Selenium committer for a while at the open source project. Although 90% of the code is Java, there's still Python stuff there. There's still good stuff. There's JavaScript as well, which is kind of okay. I've been working with Selenium and Python for over 6 years at this point. And in my set of skills, I would say that I'm pretty solid on Selenium, Python, and JavaScript the most. How about Sauce Labs? Well, we have browsers in the cloud. We have a cloud of VMs with pretty high limits of parallelization, and we serve those browsers for users. So if you guys want to test using IE6 on Windows XP, or IE10 on Windows 8, or maybe Safari on iOS 6.0, you can just fire your Selenium test pointing to Sauce Labs, and it'll all magically happen so that you don't have to pin your CPU or your slow Mac to get it done. So you can use the power of the cloud for very fast browser interactions and then move on. We also capture full videos, screenshots, and logs of the execution. So once you run a test, you can actually go to our site and see the full video of what happened with the browser, having the browser open google.com and then typing whatever you wanted to type and stuff like that. I'll show you guys the demo if you're interested afterwards. The point is Selenium right now. In the agenda, first of all, I want to kill the myth that Selenium is a voodoo magic complicated thing that I don't know how it really works. It's really unreliable, and I don't want to deal with that. Selenium is just a library. It's up to any Python developer to use it or not. It's simple to use. Is reliable. Pretty much every big player in the internet nowadays is looking into or using Selenium to drive client-side JavaScript tests. So it's definitely something you want to look into. We're going to talk about some testing best practices and then some Selenium best practices, and then some advanced features and some more details about Selenium, and then we're going to open it for a Q&A. If you guys ask any questions, I brought some hot sauce. I can't just give them, so if you ask questions, you get hot sauce. I only got 16. We don't make sauce. It's just a marketing move, but it's actually pretty all right. So first of all, Selenium was created in 2004. That's almost 10 years ago. It was 100% JavaScript. It was just a piece of JavaScript that would get injected into a website and would drive the browser by firing JavaScript events over and over. WebDriver came around later to solve kind of the problems that just simple JavaScript wouldn't address, like getting around the JavaScript sandbox, being able to download files, read multiple domains at the same time. And Selenium basically decided to migrate all the community to WebDriver. So they called it Selenium 2. It was basically complete ditching the Selenium codebase, moving to WebDriver, calling it Selenium, and all the community and developers were happy. We're still using Selenium. Good news is Selenium has become a W3C standard. We're still finishing up the drafts, and I say we probably shouldn't. Some people that are very smart are finishing up the drafts to make the Selenium spec part of the standard, and that means that all the automation bits, all the parts that take care of driving the browser, making clicks and types are going to be part of browsers. And browsers will be opening a port that you can talk to from any client binding that are very thin and simple, to tell it to open a website, click around, get text, whatever you want to do from the browser. So that's really good stuff. That means that the Selenium codebase will fully disappear and become just client bindings. And the code will be maintained by browser developers, and it'll be robust, and it'll just come out of the box with any browser that you start using. So I want to make a quick demo on how to use it. I think this will kind of kill the whole myth on Selenium being hard and Selenium being that thing that QA people do for their testing magic. First of all, Selenium is not a testing tool. Selenium is a browser automation tool. Can you guys see that? All right. So I'm just going to open a REPL and get some stuff going here. So from Selenium, I'm going to import WebDriver. Wow. Some kind of UI glitches here. Browser equals WebDriver. Wow. And as soon as I instantiate, create an instance of WebDriver.chrome, a browser comes up in the back. Although I'm not really doing anything in the UI, I instantiate this thing, and now it's kind of a representation of a browser. Let me move the browser to this side so that this looks easier. So now I've got this browser thing, and I can tell it to get google.com, for example. You can see that the call is blocking. So as soon as I call browser.get, it's going to block the main thread in the REPL. And it's going to make the browser do some stuff, load google.com, and then return. So now I can access attributes in the browser as if I was a user going through the UI. So I can do browser.title, and it'll tell me what the current title of the browser is. And you can do fancier stuff, of course, like saying search equals browser. I'm going to find the search input. So find element by name. And I'm going to call it search. So now I've got a handle of the search. And I can do search.sendKeys. And I'm going to type Python meetup. So as soon as I call that, it's actually typing in the browser real time. And this is really fast. This is actually already built in Chrome. So it's basically Python sending HTTP requests to Chrome, and Chrome executing whatever I tell it to do. So now, of course, I can do search. I can do browser.title. And it'll tell me what the new title is, which is Python Meetup Google Search. And I can pull the whole DOM and do other stuff with the browser itself. So Selenium is not really a testing tool. Selenium is just a way to interact with browsers from code, an API to browsers. And it's very powerful. Of course, testing at the end of the day is 99% of the uses that you have for this kind of stuff. But it's still something that is good for you guys to have in your toolkit. So I'm going to kill it and go back to the slides. All right, so what people use Selenium for and real browsers? Well, testing, of course, is 99% of it. If you want to test a website, if you want to test a client-side JavaScript of a website, and if you want to do it cross-browser, there's no way to do it without real browsers. And nowadays, Selenium is kind of the tool for that. You can still use things like Phantom.js. I think it's a JavaScript fake Chromium implementation. But still, if you want to test it on IE, what happens with the JavaScript, the JavaScript VM running on IE, what happens with it in Firefox, the stuff that you will need to do, and real browsers are the way to do it. People use it for high-level monitoring. Sometimes you just have a lot of Selenium tests. I'll get you in a second. People have a lot of JavaScript in their websites, and they just want to check it real time in the production application, and they use Selenium for that. I've seen people capturing screenshots with Selenium. So just open a bunch of pages, capture a screenshot, which is part of what the Selenium API provides, and then compare them across browsers, just to check for CSS issues and stuff like that. It's kind of a headache to do it that way, but I've seen people do it. There's a lot of people doing client-side performance analysis. Another part of the Selenium API is getting logging out of browsers. So you can actually start a profiler on the JavaScript VM on the browser, and then do all the Selenium stuff that you want to do, any kind of browser interaction, and afterwards just pull out an HAR file with the whole performance stuff. At Google Test Automation Conference in New York a couple of weeks ago, there was a Googler talking about how they reuse all of Google's tests, Selenium tests, to actually measure client-side performance in all of Google's sites. And it sounded like an awesome idea. It's one of my 20% projects to build that just transparently on Sauce. So if you just run a test, you go there and you'll see the performance dump without having to really do much yourself. And I've even seen people use Selenium to just basically record screencasts. Just drive a browser, record a video of the whole thing, send it to your acceptance task, the stakeholders of your project, or just put comments and audio and make it a video online. It's even a convenient tool for that. Anything that would actually be tedious to do by hand, it's always a convenience tool to use.
So since you're talking about other libraries, what do you think about Testacular, which they renamed Karma?
Karma, I don't fully remember what the implementation is, but what I've seen a lot around is just JavaScript driving the browser internally. I think Testacular is just, or Karma, it's actually just JavaScript embedded in the browser. That's what Selenium 1 was. There's nothing wrong with it. It's cool that the good part is that you only write the code once. It's just JavaScript and it works in every browser. But then taken to practice, there's a lot of quirks, and browsers understand event firing differently. So typing in some browser will not work in others, or maybe doing it with jQuery will not work. While in Dojo it does work. There's a lot of little tricks like that, and there's also a lot of things that just fall out of the spectrum. Like you will not be able to download files, or you will not be able to interact with browser-level pop-ups like alerts. Alerts completely block the JavaScript thread, and there's no way for something that is just running in the JavaScript thread inside the application for to actually interact with that, access it, read it, and so forth. In the same way, you can't really do cross-domain, and by that I mean you can't have a tab opening my website and another tab opening Bank of America and have JavaScript in my website being able to interact with Bank of America, of course. You won't be able to read your bank account information for obvious security reasons. So browsers prevent that, and therefore any kind of JavaScript library just will not be able to drive multiple domains in the same thread. So I'm sure that nowadays, several years later, there's going to be tricks to maybe circumvent some of these. But I think the point that Selenium is becoming a W3C standard is big enough for everyone to just confirm or just accept that it's the way to go. Every browser vendor accepted it. Google already implemented it in Chrome. The Opera guys implemented the now extinct Presto engine, I think is the Opera thing that they replaced with Chromium. Firefox is building it into Firefox, and that's actually the tool that they're using to test Firefox OS, which is a new mobile Firefox platform. Well, I've got a service I can recommend called Sauce Labs. We actually run Selenium tests in parallel in the cloud. But if you want to run things faster locally, Selenium Grid is a tool to create your own load balancer on top of Selenium with multiple machines. Each is going to be running a browser. Another option is to use Phantom.js. There's a driver for Phantom.js in Selenium. So it's going to be a headless Chromium thing. It's not legit, but it's more legit than, say, I think HTML. I don't remember the other fake browser. Yeah, HTML unit and stuff like that. Well, we're going to have time for questions later as well. But let's focus on testing, because that's where what you guys are here for. So I have some advice for testing. This is not purely Selenium stuff. But it's always good to get reminded of the fact that automated testing is just coding. The goal is different. The goal is to test another application, but it's still code. And you got to apply good practices for that code as well if you want to make it maintainable, robust, and not just be a headache that you're going to abandon 3 months in the project. So don't repeat yourself. I think everyone here at this point has heard what DRY means and what's going to save you guys from. Let me show you an example in the testing land of why you want to keep don't repeat yourself in mind. Okay, so I'm going to make that bigger probably. Is that okay? Cool. So this is a good example of a test case. I don't know if you guys know the unit test module already is the way you write tests in Python, and Selenium just piggybacks on that. Selenium is just a library that you put inside your unit test. So in this specific test, I have 2 tests. One that I'm going to type my name in Google, and now I'm going to try to find if there's a link with my website in the href. So I'm just trying to make sure that going through the Google UI, I can find my site on the top, on the first results. And another test is kind of simpler, but it's going to google.com, typing Sauce Labs, and then searching that Sauce is in the browser title. So this is a bit more of a making sense to use Selenium kind of stuff. For the other test, you could simply use some kind of Google API without having to pull up a full browser for it. While in the other one, you do want to check that the browser title gets replaced, and that's done by JavaScript, and there's no way to do it without a real browser. But if you compare these tests, let me make it a bit smaller. If you compare these tests, let me show you what they're actually doing step by step. Step 1, we're creating a browser instance, as I just did by hand. Step 2, we're getting google.com. Step 3, we're finding the query input, typing my name by sending keys, submitting, and then we're waiting for the results to come up because, of course, asynchronous JavaScript browser stuff, you gotta wait a bit for it to come up, and I'll show you how that happens later. And then we find all the links in the results, and then iterate on every link, pull the href out, and check that it's out. If my website is in it, I break the for loop. If I reach the end of the for loop, I don't know if you guys know what an else means. In a for loop, it means you reach the end without breaking. And that means I didn't find my site, so therefore fail. And as soon as I fail, supposedly I'm going to call browser.quit. In the other tests, you'll find a lot of very similar code. I'm basically instantiating a browser, getting google.com, typing sauce labs, submitting, waiting for results, and then asserting that sauce is in the browser title, and then quitting. So there's a ton of duplication here. And what's the problem going to be with all this duplication? Well, first of all, how about if Google changes the locator to find the search field, the Q here by name? Well, if Google changes that, I have it hard-coded in 2 places. So I basically have to go to every single one of my tests and replace it. If I have 500 tests, it's going to be a headache for sure. So you want to take that out. There's also something else that is being repeated. How I instantiate the browser. In both, I'm instantiating Google Chrome at the beginning of the test, and I'm setting implicit waits, which is something that I kind of want to use across the board. So I could totally take that out into the setup of my test. Both tests are using google.com. I could also take that out. That's also a hard-coded thing along the ways. And there's also even duplicated logic that is multiple steps. I am duplicating the way I search for something in Google. If Google decides to create 2 fields and maybe having you click 2 buttons in a row, well, I'm going to have to go to every single test that is implementing this logic of typing, submitting, waiting, and replace that and fix it, which is it's very painful. So this is a kind of a fixed version that I just wrote based in the same logic, where I'm implementing, first of all, setup and tear down. If you guys don't use this in your own test, you better do. Their methods, they're built into the unit test case class, and they're going to get run before and after your test, independently of whether they pass or fail. So I can be sure that browser.quit will be called independently of whether an exception is thrown in my own test and my test fails, or whether no exception is thrown and my test passes. I'm also separating the browser instantiation and the implicit waits out and the opening of google.com. And I also factorize something else out, and it's the logic for searching something on Google and waiting for the results to come back. I call it search, and this is probably not the right place to put it. You probably would have a framework at this point, which is in the Selenium, in Selenium land, it's called page object model. We'll talk about a bit later, but it's basically just pulling code out and tagging it with a name that is very easy to read when you read actual tests. So I'm pulling all the searching and waiting, and if you read my tests now, they're very, very simple. There's no duplication across the board. So in the first one, I just do for link, in searching my name, check all the link attributes and stuff, and pass if the website is there. And in the other one, it's super simple. Just search for sauce labs and assert that sauce is in the title. There's no duplication. Fixing any kind of changes on google.com will be just as simple as going to the right method and modifying it. So keep that in mind. Duplication can happen in tests, and it actually happens a lot. Okay. Another tip that I want to give, even though it doesn't really apply to Selenium, because Selenium is not really running in the same thread as the application is, so you can't really mock stuff around. But I found mocking so awesome that I just wanted to dedicate like 15 seconds to it. If you guys are running unit tests or functional tests where you are in the same thread as the application, mock all the things. Mock anything that is not under your control. If you didn't write that piece of code, you don't have to test it right now. So write your test very focused on the piece of code that you wrote, and anything else that could make it slower or less reliable, mock it out and make it return a default value. It is going to be sacrificing coverage, of course, but if your tests are unreliable, you may as well just not have tests. You can't have tests that you can't trust on. They need to be 100% green when your application is working correctly, and they need to be red when the application is not. So mocking anything out that is not under your control and it's not really part of the application is crucial for this. It's a funny story. I was actually trying to write an example on how to mock the open built-in. I spent like 3 hours and I decided to just not do it because it's a headache to use mock. Once you get used to it, you can kind of fly with it, but it's not fun, but it's very powerful. So there's no example for this. Another thing I wanna talk about is writing small tests. Focus your test on what you want to confirm. Don't write a test like this. I don't know if you guys can see that, but I can make it easier. Don't write a test that does this. Test, sign up, login, search, add to cart, check out, and log out. I've seen this so many times. You'll think it's awesome. You'll think it's very fast because it does all the things together. So I'm chunking stuff together and I'm saving time. But the reality is that there's a lot of drawbacks to this. And let me talk to you about some of those. First of all, one failure in this test will basically block all the other workflow, the rest of the workflow from going through. So your test results, let's say you break the sign up in your application, your test results, all they'll say is you broke the sign up. I don't know what's going on with the rest of the application. I just know that the sign up is broken. So you can spend 10 minutes to fix the sign up, and as soon as you commit, you figure out that the login was also broken. And it was probably a very similar bug, but you didn't get to fix it because you didn't even get to know that it was broken. So writing isolated tests, one for every single feature in your application, will give you a very detailed report as soon as every build ends, telling you what's actually going on. And there's a tip on how to do that that I'm going to share in a second. Another disadvantage is this test is going to take a while. Tests that go through a lot of different things, and this even scales at unit test level. It's not just Selenium. In Selenium, it's just more visible. When you write a unit test that does 25 things at a time, yeah, it's going to take 4 milliseconds instead of 1. Maybe no one really cares, but when you have thousands and thousands of tests, it actually starts becoming important, and you actually start wanting to parallelize things more and break it in pieces. If you break a huge test doing 5 things in pieces and you run them in parallel, you'll get your results way faster, and they're going to be a lot more independent from each other, which is what you're looking for. Avoid inter-test dependencies. This is very common, especially when you have hundreds of tests across the board. Inter-test dependencies are generally caused by execution order. When your tests are all running in the same order every single time, that's gonna start making people lazy. I'm gonna start making people rely on data from different tests for my own tests, so I don't have to generate. If I am running my test after this account has been signed up, well, I don't have to create an account myself. I can just reuse that. The problem is that when you increase parallelization or when the execution goes randomized, then things are going to start failing because the data that you rely on is not there anymore or it's being modified by something else. And data dependencies are very, very painful to discover and address. So the main advice is make sure your tests are running in random order. Don't enforce order. That's the worst thing you can do. And I've seen so many issues and pull requests on testing frameworks like Nose and PyTest saying, make it run in order. I want to be able to run this first. And that's not a good idea at all. Never use data sets more than once. Never use the same data set in different tests. Create your data before your test starts in the setup and then destroy it in the teardown so that you're sure that your stuff is fully isolated. If it runs on its own, it's going to work. If it runs with 100 tests more, it's going to work as well. And another nice advice is wipe your database every time your build runs. So you want to start from 0. You want to have no kind of preconditions that you can't control be in the database before. Because the day you migrate your staging server and all your tests break, that's the day you're going to abandon Selenium and you're going to abandon testing and CI and you're just going to go with it and good luck. Here's a good example of a data dependency kind of in purpose created. Very simple, where you basically have the test start, and then you have a test that creates the account for the user A, and then you have the test that logs in with that user and changes the password, and then you have a test that checks that you can close the account. Of course, running this in parallel or in separate order is going to break things, and it's going to take you a while to figure it out. In this case, of course, it would be very obvious, but when it comes to complicated test suites with a lot of data states, it gets really, really hard, and it can take a lot of time. Another advice I have is run your tests automatically. Run your tests as much as you can. I think everyone here has already heard of continuous integration. I don't know if you guys have heard of Travis. It's kind of the new cool kid in the block, especially for open source projects. You just push to GitHub, and Travis figures it out by itself and runs your test. You can tell it to run on different versions on Python, and it runs in parallel. It's really awesome. You can use Jenkins if you're old school. You can use pre-commit hooks if you want to get the feedback even faster. What's important to know is that the shorter the feedback loop it is to a test failure, the faster and the easier it will be for you to address it, right? If you break some code today and you push to the build, or you push to the repo, and 2 months from now you hear that something broke, you will never call that being yourself. Like, it was not your fault. You have no idea it was your change. And if someone confirms that it's your fault, it'll take you days to figure out which change in the last 2 months was involved in breaking that and which line of code that I need to fix. On the other hand, if you get on a pre-commit hook or in a build 30 seconds after you wrote a commit, a failure, it'll take you seconds to actually go through it and fix it and at least know what's going on. Any questions? Cool. Let's keep on going. Another advice I have, I've seen this, especially in big companies, the bill is never really green. The bill is kind of okay green, but it's never really 100% green. And that to me is kind of a snafu. It doesn't really work that way. If you have one test out of 5,000 tests failing, something's broken. It's either the test or the application, which is a lot worse, but something's broken. If you run it again and the whole thing passes, it's even worse because the application is flaky. So it's hidden, so people will not see it sometimes, or people will sometimes, and your developers will have a really hard time to address it. But whenever something breaks, it's got to be priority 0 for your developers. You got to stop development. You got to be completely unable to push any new features, and you got to fix that problem. Now, you're going to say, I have 500 developers in my company. I can't block 500 people because one of them broke something. Well, there's different ways to address all this. You can have multiple builds. You can also quarantine tests. It's another option. You can tag a test and tell it, well, this is quarantine, so we're just not going to run it anymore because it's flaky. We have at Sauce something we call Flaky Fridays. Every couple of weeks, we decide, well, our stuff is, we got way too many flaky tests, so at this point, we should actually go to them and address them and fix what's going on. Another option is instant reverts. So if someone pushes something and it breaks a single test, just revert that commit instantly and assume that's the commit responsible for the failure. There's different approaches based on the size of the company, but what's important is you gotta aim for 100% green. If a test fails 10% of the times, may as well not have it because it's not giving you any help whatsoever. Having developers lose faith on the build is probably the worst thing that could happen to the quality of a company. And we've all been there. I've been there as well. I'd be like, oh, failing the build, rerun, I'm gonna go get a coffee, and then it's gonna get green later. And that's not the way you wanna address quality, especially on a serious company. And this is kind of the kind of build that you really wanna avoid. That's our build today. But it's blue a lot. We're going through a big change, and the build is not really doing its job right now. But the thing is, you want it to be 100% blue with a couple reds here and there isolated. The last advice from the testing side of things, you want to make writing tests extremely easy. That's the goal to quality in a company. You want to make your developers be able to write tests with 3 lines of code, or with 2 lines of code, or maybe even better with 1 line of code. If writing, maintaining, and fixing tests takes only focusing on the logic of the test, that's the place you want to be at. If writing a test for your application takes a developer writing 7 lines of boilerplate code, mocking a couple libraries, and spending the 2 hours that it takes to mock write, and doing all that kind of stuff, no one's really going to write tests. And if you enforce it, it's even worse. They're going to write poor quality tests. They're going to do it quickly and move on. You want to take care of all the boilerplate. You want to put your smartest developers writing frameworks that the rest of the developers will just consume to write tests. A 1-2 subclass, some kind of test case thing, like a I was talking to Julian from Django. He said that he wrote the live server test case, which subclasses unit tests, and basically starts the web server for you so that you can write Selenium stuff and hit an actual running web server. That's the way you do testing. You want to hide all the details on the test outside to a framework, and you want the developers to just assume stuff is going to work and just focus on the lines of code that are on the actions that happen with the application and in the logic. Any questions? All right, let's talk about Selenium best practices. Most of these are also good coding practices, good testing practices, whatever you want to call them, tests or code. But I want to highlight them because they're Selenium oriented as well. Number one, do not use Selenium. Never use Selenium if you can avoid it. I think at this point you've all heard when you have a hammer, everything looks like a nail. I tend to see this a lot with the Selenium crowd. They know how to do Selenium, so they want to use Selenium for everything. They want to use Selenium to boot up a VM and hit the start button in Windows and then start IE and then download a PDF and open it. And Selenium is just going to drive browsers. It's a small library. It's meant to automate browsers. If you have a way to avoid using Selenium, please do, because Selenium is not the right tool for you. Good software engineers know all the tools that they have at their disposal, and they use the right one every time. So if you want to do things like testing the status codes of your application, testing that your application returns 200 on every page, don't use a real browser for that. Just use HTTP-lib, URL-lib, URL-lib2, especially if you're in the Python world. You got plenty of tools for that stuff. Of course, you got requests, which is the right tool. If you want to hit things like testing plain HTML, if you want to check that your website's homepage has the right amount of content, the right title, don't use Selenium. Don't use a real browser. Selenium drives a full browser with rendering engine, a JavaScript virtual machine. It runs on top of an OS that is generally unreliable if you're doing Windows. Don't use Selenium. Selenium is slow and bulky. It is a necessary tool for testing things like cross-browser client-side functionality. And we all at this point have that. But if you can avoid using Selenium, use the right tool. This is what we were talking about before that came up in the question. Generate application state. A lot of times, I mean, any decently complicated application will have a lot of state in the browser based on cookies and what's going on through the UI. So for example, if I'm testing Amazon.com, of course I will not be able to check out the shopping cart if I don't have anything in the shopping cart. Or I will not be able to get to my orders if I'm not logged in yet. And all this stuff is browser state that you need to have. And it's very time consuming. If you want to make your test very atomic, you want your test to focus on the checkout. You don't want your test to go through the login, to adding anything to the cart and check and any of that stuff. You want your test to just open the checkout, click on the button, interact with whatever JavaScript you guys have, and then confirm that it works. That's kind of the ultimate test, right? It's going to last 10 seconds instead of minutes and minutes. And if the login breaks, your test is still going to pass. If searching on the cart still breaks, your test is still going to pass, and you're going to know, okay, the checkout is not broken at least. The way to do this is, I mean, there's a lot of ways. The easiest one, and I'm going to show you an example actually, because why not? Okay, so here's our dev website. This is my version of our dev website. And of course, if you want to log in, you cannot because, oh, there you go. You get to the login, and there's a username and password and submit. And if my test relied on logging in, they would have to load this whole huge page with the header, the footer, and Google Analytics, and the Twitter button, and the Facebook like thing, and all that stuff that makes the browser very slow and that makes your test very unreliable. And this is not what you want to do. What you want to do is have something like this, which I'm going to show you very detailed. Test, login, admin. All you want to do is have your test type that, and as soon as you do it, you're logged in as the admin. No security, no password, no interaction with the UI, no loading the DOM and spending time getting the Facebook like button or anything like that. You're generating application state very quickly, very easily, and in the browser. So if I had URLs for every single interaction with the application using this, I would be able to run my test in 10 seconds. Just load 5 pages with no content other than just happened. You got an item in the cart and you got to the checkout page. And then I can make my browser go to the account page. And now I'm logged in, and it's awesome. Of course, you don't want to deploy this to production. Just make sure you don't.
How do you assert that you're generating the correct state?
Well, that's tricky, right? You're faking application state. One way or another, it could differ at some point. The way we're doing it is we're calling the same controller methods from the fake API than from the original API. At some point, they differ, of course, but we try to put as much similar code together as we can. So they only differ in the rendering of the template and other details like that. It's not ideal, but this is all about trade-offs. There's no perfect solution or silver bullet. You gotta know what you're trading, what you're sacrificing, and what you're getting. You get a shitload of performance, and you're sacrificing coverage.
How do you know you're testing the same code paths?
You are not. You're definitely not testing the same code path. Of course, you want to have a test for logging in. That's for sure. And that test is going to go through the whole UI. It's going to type the username and the password, and it's going to check that you got to the admin page. But all the tests that are not testing the login do not need to go through that flow. It's actually completely redundant and unnecessary. So you can skip that flow for all the tests that go later, and for the test that needs to do the actual login, yeah, do it that way and get it. There's like even smarter stuff you can do. You can actually, if you take all this to a framework, you can make your framework with a switch automatically make it go through the right UI. If you're in like a special build that you have that you want it to go through the whole UI, so calling login will actually log in through the UI. Or you could have it in a dev setup, be like, okay, I'm running in a developer's box, so login will actually go through the fake login, and it's going to be faster. So it's a matter of trade-offs, right? How much you want to sacrifice in coverage and how much you want to gain in performance. Yeah.
What's your best practice for ensuring that you don't put any of your test picture?
You just hire smart developers, and that should be it.
A lot of trust.
Mm-hmm. It's a lot of trust. It's part of the trade-off, right? You're sacrificing a bit of security on the improvement of making your tests reliable and fast, and improving your developers' lives, basically. You could write tests. I mean, we put everything under test, every magic URL to be under test, and then we check that we cannot open any route that is under test. It depends on how much of a commitment you want to make. Of course, if you're gmail.com, there's probably a bit of more hoops you're going to have to jump to get this through the goal line. But if you're a startup and if you're a 3-employee company, there's no reason to really not do this and get the gains out of it. All right. Another tip I have, and I think I coined this at Sauce, we call it guinea pigs, and they're basically this. It's taking a complicated widget out of the whole workflow of the application and putting it in a very simple blank page. And it's kind of like the same thing as generating application state by avoiding the whole thing and just putting in a simple plain page. And let's use the example of testing gmail.com, and you want to test a compose thing for an email where you have all the making bold and italics and linking and stuff. Well, if you follow my approach, you're going to write a single test for every part of the UI. So the bolding, the italics, the underline, every one of those buttons will have its own test, and probably will have multiple tests for different parts of the behavior. That means that you're going to have to go through the whole workflow a lot. Logging in, composing, even generating the application state could not be the most efficient way to do it. So I like to just take stuff out like such a widget completely outside of the page, put it in a blank, on the side, put it in a blank page, and then run your full battery of tests, your 700 tests, hitting every single button in every single case. And then for the rest of the times you actually use a widget in the workflow, maybe write a smoke test or 2 tests that check, yeah, the integrity is okay, so it's probably working as well as the one that we took out of the page. Again, you're sacrificing a bit of coverage, you're getting a lot of performance gains.
Can Selenium work with Flash objects?
Selenium kind of does work with Flash objects. It doesn't really. Flash is just a black box that you put in your page in the same way as Canvas nowadays is, or Silverlight, or God forbid, Java applets and stuff like that. It's just a black box embedded in the browser. The good news is that for Flash, there's a library that you can embed in your Flash application. And what it will do is it'll open the door for JavaScript to interact with the app. So JavaScript calls a special API that this library opens. And then inside the Flash thing, there's going to be clicks and types in the same way. So Selenium can do JavaScript. And if you put a library that can listen to JavaScript, you're done. And there's several libraries. They're all open source. One of the guys working at Sauce, Adam Christian, was involved in one of the projects that did Flash automation in the past. And God, he hates Flash. Another tip I wanted to share is to parallelize your tests. As we were talking, Selenium is slow. There's no real way to speed up actual browsers running in actual OSs, in actual VMs. So run it in parallel. Nowadays, computing power is a lot cheaper than developer time. So just get a lot of VMs, put them in Amazon EC2, give us some money, and we'll take care of it. And this is how you do it in, let me see if you guys can see that. This is how you do it in Python land. This is nose. I'm a nose guy, but you can do PyTest as well. Just call it with -- processes, the amount of processes that you want. Nose has this special process timeout thing. The default value is set for unit tests, so the process will actually time out like 10 seconds after it started. So you want to pass a more reasonable process timeout for a real browser. Something to keep in mind is, generally when you run unit tests in parallel, you want to focus on how many cores you have, because unit tests are very CPU intensive. So increasing the parallelization to like 20, if you only have 2 cores, it's not really going to make you too many gains. It's probably going to be counterproductive. When it comes to Selenium, Selenium is very, very IO driven and IO bound. Selenium is making API requests to a remote process every time you make a command. So when you call click, there's an IO going to the browser and telling it, click on this element, and then the browser responds, okay, the element has been clicked, and stuff like that. That could go through the whole internet if you do it on Sauce, or you could go locally if you do it in your own laptop. The thing is, it's all IO driven. So increasing the amount of threads to more than the cores your laptop has is completely safe. I think in my own MacBook Pro, not the Air, but a Pro, I got to run 6 browsers in my own laptop before things started getting a bit wonky. But yeah, think about VMs, think about the cloud. Page object models. Any questions? All right, I'm gonna have to be taking a lot of hot sauce with me today. Page object models. Page object models are simply just an abstraction layer on top of duplicated code. In the same way I had abstracted a search method that is going to take care of interacting with the UI, and that from my test I can just call and ignore what's actually going on in Selenium. Page object models are just that. It's just a nice abstraction on top of your UI. You want it to be very tied to the actual application logic. And let me show you an actual Sauce test for this. Because that's how cool we are. I can actually show you our code. At least a test one. So I'm going to open. All right. So in this test, we're actually instantiating a jobs page object. And we're sending it to, oh, you guys can't see this stuff. No, you can. Let me know if it's too small. So here we're instantiating a jobs page object. We have a jobs page. Let me show it to you real quick. So this is what it looks like. It's all full of red, but that's part of my dev setup. So this is where you have every single Selenium test that you run today, and they'll tell you their status and the environment that they run on, and you can filter them by name. So I can say Python, and it'll only show you the Python ones. And you can do even smarter filters like tags and the platform. So I only want to see the IE10 tests and so forth. So we got a lot of JavaScript running here, and we got a lot of Selenium tests that tested. So let me show you that. We have the jobs page. And well, a very simple test basically called jobs page.open, and it tells you which login to use. Another test that is a bit more complicated opens it and it waits for the jobs to be fetched from our website. A bit smarter test is actually doing more stuff. It's actually sorting it. So you pull a widget out of the jobs page, the actually jobs widget, and then you initialize all the filters, and then you sort, and then you check that the topmost, and you pull the topmost job, and then you sort it again, and then pull the topmost job again, and you assert they're not equal. It's not an awesome test, but at least it's getting to the point that I want to make, and that is there's no Selenium code whatsoever in this test. You didn't see a single Selenium interaction in my whole test. And that's really good. That's the way you want to write your testing frameworks. You don't want 99% of your developers to have to understand the Selenium API, how to interact with the DOM, how to click, how to type. You want dedicated specialists to do that part. And you want the rest of your developers to just consume from a very simple framework where they can think in application logic terms. So I can say, open the jobs page and sort by ID, and then pull the first one, and then watch the video. There's no Selenium stuff, there's no clicking, no sending keys, but for developers, it's very, very easy to write, and it's very, very easy to maintain. Whenever the workflow changes, all I need to do is go to the place where we sort and change the logic there, and all the tests will pass out of the blue. So page object models, it's just a fancy name for factorize your code in good ways and put good APIs in front of developers, which you guys already do, hopefully. George.
So basically, all you're doing is just providing a library interactions for your web page, web server.
Yeah.
Then your test is the logic to put something.
Exactly. You're providing an API to your application logic, and the test consumes that. And it's actually really, there's a lot of frameworks nowadays. I don't know if you guys heard of Cucumber in the Ruby land. I think there's Lettuce in Python. That's kind of forcing you to do the same thing. It kind of forces you to write in English what you want your application to do. I'm not a big fan of writing code in English, but there's a good thing to that. It forces people to think higher level. And a framework like this does it as well, and it also enforces good syntax and Python code, which is also awesome. So I kind of like this as a replacement for things like Cucumber or any of the other frameworks where you describe a BDD way. Yes, the question is, if you come from a company where you have a solid QA side of things and you're starting an application from zero, which are the top 3 bullet points that you would say are going to pay the most when it comes to testing, right?
To write the actual application, how do you make your application
more testable? So how do you make your application more testable? Number 1, make your developers write tests. That's basically, that's going to pay off so much. If you tell them, you guys have to write the test for the application, they'll take care of the application being testable for their own test to run. If you have a big company and the QA team is separated from developers, you're going to have to start enforcing good coding practices on the UI of the application. Things like an expressive DOM, where everything has an ID, especially a unique ID. I think that's basically going to pay off as much. Keep the UI, the identifiers in the UI solid, so don't change them when you change the application side of things. And keep your QA and your development team very tight, because they want to collaborate. You don't want them to be enemies as they've been for years back, where the QA are the people that are finding out the bugs of the developers who hate QAs because they're not technical. You want it to be a collaboration. Nowadays, lean companies are moving towards, we all do everything, we're all a team, and we work together. And that really pays off when it comes to testing, and therefore quality.
Are there any favorite JavaScript libraries or frameworks that you find are easier to build tests against, like templating libraries, different interaction libraries?
At this point in my life, I don't write tests as much to actually tell you what the new cool kids in the block, how friendly they are. Well, Jasmine is kind of a library to write JavaScript unit tests, not really to write the JavaScript UI of an application. I know that ext and all the libraries based on ext had a lot of issues because they would generate identifiers in the UI dynamically. Therefore, it was just a very painful process to actually find elements and know how to interact with them. So it would take the best tool that a QA guy or a Selenium writer has, which is solid IDs, and it would randomly generate it every time the page refreshes. So it was very painful. At this point, I think Selenium has matured enough, and libraries have gotten to the point in which best practices on the UI layer are pretty much enforced across the board. So I don't think I have any favorites from what I've seen around. George?
Just want to follow up what developers can actually help you do to make the site testable is actually having some backdoor way of introspecting the data objects that are being passed through the web browser. So you might be inspecting the DOM, but in order to check whether the DOM state is correct, you can actually check the data state, and the data state is something else other than what your DOM is expecting. Then you and that actually helps bringing the piece of code that you're testing out into your own HTML page, because you can just actually mock data objects and then have it influence the DOM.
Yeah.
And then you can remove your whole application server from the whole script.
Yeah, nowadays I think we've all gotten to the point in which we understand that gray box and white box testing is a lot better, a lot faster, and a lot more reliable than black box testing, where you don't know how your application works. At Sauce, we even reuse the database layer for the test and for the app. So if we need a new account, we create it with the account, the username model that the application is going to use. And if we need to check for it, we check for it with the same layer. So the code is just Python code. And it's one of the advantages of having your test and your application written in the same language. You can just share code across the board and use it along. So yeah, using the database is a huge tool to actually check stuff fast, reliably, and not having to depend on the UI for everything. At the end of the day, for coding tasks, the UI is the slowest path to any destination you want to take. Generating application state, checking the application content. The UI is always the slowest. That's because humans are a lot slower than actual machines. Those are the ones that are going to be running your tests.
So XPath used to be the way that finding elements, interacting with elements. It always seemed sort of unreliable to me. Is it pretty much frowned on these days, or?
I am famous in the Selenium community for writing, for giving a whole talk on why XPath sucks and why CSS is the way to go. That was in the Selenium 1 days, when Selenium actually used JavaScript libraries to find elements using XPath and CSS. So Selenium was using Sysl, which is the jQuery thing, and that was super fast. And for XPath, it was using something else, open source, but it wasn't really that good. Nowadays, both are going to be done by the browser. The browsers already came with the standard that is a CSS query, CSS selector, or CSS query. I don't fully remember it. Selenium just lies that to the browser, and the browser takes care of it. So both are going to be just as reliable and just as fast. I still lean towards CSS just because no one really knows what XPath is and how to write it, except for Selenium guys. So your developers will really know how to write CSS. Everyone writing an application at this point had to style some element in the page. So CSS is just going to be more readable for most people in the company. It's not as powerful as XPath, but it's only in like 5% or the last 2% of the cases where you actually need to do things like going down a tree and then going up and going down on the other direction that you actually need XPath. For the rest, CSS is all right. It's more readable and more people will be able to do it. So I tend to lean towards CSS just for that.
Cool, thank you.
All right, I'm going to keep on going with the slides, but save those questions. I'm doing a lot of mirroring here. Back. All right. Another trick, use JavaScript. Calling execute scripts, you'll be able to get right into the JavaScript VM inside your application, the JavaScript context inside your application. So you can check stuff like global variables in the window. You can even call events if you need them. You can check that Ajax is going on. You can do pretty much anything. And this is kind of gray box testing again. You're not really clicking and typing, but who cares? If your test passes and it's really giving you the coverage that you're aiming for, calling JavaScript is great, and it's a great tool that you should keep in mind for your stuff. Another piece of advice I had is using waits for your tests. You really want your test to be able to handle asynchronicity in your app. You want to be able to handle Ajax and stuff that is not loaded at the time you need it. And that happens a lot in websites, right? I click a button, and something renders. And if I'm fast enough, the thing that renders is not going to be there at the time I'm looking for it. Human beings tend to be slower than machines, so it's not a problem for us. We know that when we click a button, something will happen. Selenium is not as smart, and you got to tell it how to do it. So here's a quick example I had as well. So the first one is using implicit waits. It basically tells Selenium to implicitly wait for elements when they're not available. It's all inside Selenium, it's built in, and it's implicit. That's why it's called implicitly wait. It basically means whenever I'm trying to find an element in the page, if the element is not there, it'll make Selenium recheck every half a second for the element to become available. If after 5 seconds or whatever timeout you pass it is not there yet, your test will fail, Selenium will raise an exception, and the stuff will move on. But if the element appears 1.5 seconds later, Selenium will return at 1.5 seconds, and your test will keep on going. So your test is now a lot more flexible. When your application is slower and it takes 3 seconds, the test will still pass. When the application is fast and it only takes a split second, the test will be fast as well. That's the easy way, right? But Selenium is all about explicit is better than implicit. So Selenium provides a WebDriver wait class or helper that you can use, and you basically are being explicit about the fact that the element will not be there as soon as you need it. So you instantiate a new WebDriver wait, you pass it the Selenium browser, and you pass it the timeout, and then you tell it, well, wait until the presence of element located by ID search. And that will explicitly wait for you and return the search as soon as it's available. So it's basically doing the same, but in this specific case, you do it by hand, and in the other one, you set it up front, and every single find will automatically or smartly do it for you. Whether you want to do it explicit or implicit, it depends on you and how much you apply to the Selenium Python. I sometimes like my tests to just be shorter and simpler, but it really depends on you. Another big part of the Selenium workflow for developers is to debug failures. 99% of the times, people are actually fixing tests rather than writing them. We all write tests. It's very easy. We're all developers. Writing code is easy. But when tests fail, how do you figure out what actually happened? Selenium tests are so high level, running on the top of the stack. So it's so hard to actually figure out what actually broke the workflow, whether it was the database that it was flaky, whether the controller or the view were broken. It's really hard to figure all this stuff out. So there's different stuff that you can do. At Sauce, for example, we record full videos of the stuff, and people end up finding that the videos are more valuable to them than the cloud and the parallelization and getting pristine VMs every time. The videos by themselves are actually the value that they're looking for. Capturing screenshots every once in a while so that you know where the application is at over time. Capturing the page source and the HTML, and even better, printing the full traceback of the server-side failure in the page, in the view. A lot of web frameworks will do it already, right? If you're doing Django and there's a 500 error, some kind of server-side exception, Django will render an exception page for you. And you could use Selenium to navigate that DOM, pull the exception out, and print it in your results in the same way a user would see it by hand and pay attention to it. I have an example of that, but I don't want to take too long. One last thing I wanted to show you guys. This is going to be a real-time video. So this is Appium. It's a fully open source project. Appium GitHub, Apache 2 that we're working on for native application testing, native mobile application testing. So if you guys are doing iOS or Android apps and they're fully native and nice and they rely on swipes and all that cool stuff and pinching and the Selenium API is pretty all right for that, actually. It's meant to be interacting with UIs. Every vendor has their own kind of lame option like UI Automator and all the other stuff that they provide. Well, Appium is kind of using those interfaces to just provide a Selenium remote execution on the protocol. So you can write your tests in CoffeeScript or JavaScript or Python and then exercise it on the application. So here you can see the simple test. On the right, you'll see the Android emulator. And below it, you'll see the iOS simulator. So that's why it kind of looks like an iPhone, but it's actually an Android phone. So now the tests are running, and Android is hopefully going to open an application and start doing stuff with it. Not hopefully. It's actually going to do it because it's a video. That's how I do demos. So now it's typing stuff in the UI and logging in. Woven is an early user of Appium, and they're super happy with it. And they gave us their application as a demo because it looks really nice. Demos are a lot better with real apps than just forms and stuff. So it's clicking around through images and doing stuff with them. It's pretty fast, actually. We're now working on putting this in our cloud so that, again, you just write your tests using the Selenium API, you put them in your CI, the actual browser, the actual emulator is running in our cloud so that you don't have to deal with installing all this machinery. So again, Woven in iOS now. They resemble pretty similar UI. The actual test that is driving both emulators, or emulator and simulator, is the same code. The only thing that they don't really share is the locators, because of course they have just different technologies built in for Java and for Objective-C to do stuff. But it works pretty well, it's reliable, and we're working on that. We're pretty excited. It's fully open source and in GitHub, so feel free to just go on fork. The name of the project, let me show you. Is Appium. You can find it appium.io. It's got a nice little website and all the badges for stuff. My favorite part, I hope we still have it. Appium wants you. It's fully open source. I don't know if you even noticed, it's got the logo in the hat. That's one of our my most favorite developer at Sauce, Bernie from Poland, who made the whole website in one night while we were all sleeping because he was in Poland. It was not Christmas. And I think that's, yeah, all I had. So if you guys have more questions, fire it away.